This is a video for AQA Further Pure Mathematics, Calculus Section 2.1, Integrals with infinite limits, but where the value of the integral is convergent. By an improper integral, we mean one that we're trying to evaluate, but where the evaluation may present some problem. For example, one of the limits may be infinite, so we might be trying to evaluate the integral from 2 up to infinity of x dx. Or the function approaches infinity at some point in the interval. So an example that might be 1 over x dx evaluated from -1 up to 1, where 1 over x approaches infinity as x approaches 0. This video will look at how we approach the first of these types, the ones where we've got one of the limits is infinity. I'm going to use this example to illustrate the method that we use. This is the function f of x equals 1 over x squared. Now we know that as x approaches infinity, 1 over x squared approaches 0. So that the height of the graph here is going to get closer and closer to 0. And we're trying to evaluate this area. The problem is, of course, that the length of that is going off to infinity. So without some other technique, it's very difficult to know whether this area is going to approach a limit or whether it keeps increasing itself to infinity. Well, the method we use to find out what is happening is to replace infinity by some value, let's call it a, and evaluate the integral 1 over x squared dx from 2 up to a, but then look at the limit of that as a approaches infinity. The integral 1 over x squared evaluates to -1 over x. So we're evaluating that between 2 and a, and then we're going to take the limit as a approaches infinity. So this will be the limit as a approaches infinity, and if we now put in our values, the top one, a, gives us -1 over a, and the second one gives us minus, and then -1 over 2. So this is the limit a approaches infinity of 1 over 2 minus 1 over a. But as a approaches infinity, 1 over a approaches 0. So what's happening is that the limit will get closer and closer to a half, and as a gets to 0, I beg your pardon, as a goes to infinity, 1 over a becomes 0, so that the limit is equal to 1/2. So we can say therefore that the area from 2 up to infinity of 1 over x squared, or the area under the curve, is equal to a half. So the integral converges with a limit of a half. In a separate video, we'll be considering cases where we have the same scenario, a limit of infinity, but where the evaluation diverges rather than converges, as this is the case. So a summary of the method then If we've got infinity as one of the limits, replace that by a and then evaluate the integral as normal, but look at the limit when a approaches infinity. That's the end of this video. Calculus 2.2 will look at the case where the integrals are divergent.